This chapter introduces how MiniTab and Excel support the DMADV methodology. These tools help with data analysis, visualization, and decision-making. Excel is mainly used for data collection, basic calculations, and charts. MiniTab is used for advanced statistical analysis like DOE, regression, and capability analysis. Using these tools improves accuracy, efficiency, and reliability in design projects. The goal is to support data-driven design decisions throughout DMADV phases. DMADV focuses on data-driven design decisions using statistical and design tools. MiniTab is mainly used for statistical analysis and modeling. Excel supports templates, matrices, prioritization, and documentation. Each tool plays a role in different DMADV phases. This chapter explains which tool to use, when to use it, and why it is important. DMADV is structured into 5 phases: define, measure, analyze, design, and verify. Each phase requires different tools to support decision-making. Excel and MiniTab are used based on the needs of each phase. Excel helps with organization, planning, and prioritization. MiniTab supports statistical analysis and validation. The goal is to apply the right tool at the right phase in a practical way. The define phase focuses on understanding customer needs and project scope. SIPOC, created in Excel, is used to map the high-level process. It identifies suppliers, inputs, process outputs, and customers. SIPOC helps visualize the current process flow. In DMADV, it is used to identify gaps and areas for redesign. Voice of Customer (VOC) is collected from surveys, interviews, complaints, and focus groups. Excel templates are used to capture and organize VOC data. Excel helps in grouping, filtering, and categorizing customer feedback. Affinity diagrams, created in Excel, group similar VOC statements. This helps convert raw customer feedback into clear customer needs, such as ease of use. Kano analysis helps classify customer requirements into must-be, performance, and delighter needs. Excel is used to create Kano evaluation tables and graphs for easy analysis. In phase to measure, the focus is on converting customer needs into measurable CTQs. CTQ trees, created in Excel, break needs into drivers, requirements, and measures. This ensures customer expectations are translated into clear, measurable performance targets. A data collection plan defines what data to collect, how much, who collects it, and how often. It also specifies the measurement type to ensure consistency. This step is essential before any statistical analysis. Gauge R and R studies done in MiniTab evaluate the measurement system. They check if measurements are accurate, repeatable, and reproducible. MiniTab provides percent contribution, study variation, and graphs to assess reliability. Descriptive statistics in MiniTab summarize data using mean, median, standard deviation, range, NIQR, box plots, and histograms help visualize data distribution and variation. These tools help understand current process behavior. Process capability analysis shows how well the process meets specifications. Key metrics include CP, CPK, PP, and PPK, along with capability histograms. Results help decide whether process redesign is required. QFD quality function deployment converts VOC-CTQ design requirements. Excel is ideal for QFD because matrices are easy to create and update. In Phase 3, Analyze, the goal is to develop concepts, evaluate alternatives, and finalize design direction. Brainstorming matrices in Excel help generate multiple design ideas. TRIZ contradiction matrix resolves design conflicts, for example making a product stronger yet lighter. These tools guide creative, data-driven design decisions. POO matrix in Excel is used to compare design alternatives against criteria like cost, functionality, safety, simplicity, and performance. It produces weighted scores and a comparison matrix. Helps identify the best design option based on objective evaluation. MCDA multi-criteria decision analysis in Excel uses weighted scores to select the best option. Useful for choosing technologies, suppliers, or service methods. In phase 4, design, the focus is on optimizing design parameters using models and experiments. This phase relies heavily on MiniTab for statistical analysis. Regression analysis in MiniTab builds predictive models y equals fx, for example cost equals f material thickness. Outputs include significant factors, coefficients, and model fit r². Design of experiments DO is the most important tool in the DMADV design phase. It helps identify key inputs x's, study interactions, and optimize settings. Types of DO include two-level factorial, fractional factorial, Tagachi designs, and response surface design RSD. Key outputs from MiniTab are Pareto charts, main effects plots, interaction plots, and optimal settings. DO ensures data-driven, efficient, and optimized design decisions. Monte Carlo simulation Excel's MiniTab evaluates design robustness under uncertainty, for example financial risk or process variability. Tolerance design in MiniTab calculates required tolerances to ensure reliability, for example assembly parts. In Phase 5 verify, the goal is to validate design performance before final rollout. These tools ensure the design is reliable and meets customer expectations. Control charts in MiniTab monitor process stability over time. Common types include XBAR-R, XBAR-S, IMR, P, NP, and U. C charts. Monte Carlo simulation Excel MiniTab can also be used to assess variability and predict performance under uncertainty. Both tools help ensure the process is stable and capable before full implementation. This slide focuses on Monte Carlo simulation using Excel MiniTab. We use final capability analysis in MiniTab to check if the process consistently meets customer CTQs. Excel dashboards are used to track key metrics like defects, cycle time, SLA, production volume, and customer satisfaction. The summary table shows how DMADV phases align with MiniTab and Excel tools. Overall, it highlights a data-driven approach for analysis, optimization, and performance verification.